Hello, in this video we're going to look at the Nobel Prize in Physics for the year 1909, awarded to Carl F. Braun and Guglielmo Marconi, contributions to the development of wireless telegraphy. You see one of the original cathode Braun used in his work, and here you see Marconi at work in 1897, demonstrating his radio equipment. And now let's start with the information. This is all coming from the Nobel Prize site. This is a direct quote, as you can see, about Carl F. Braun and what he did. In the late 1880s, a previous unknown type of radiation was discovered, radio waves. It was found to have the same nature as light, but with a greater wavelength. Various physicists and technicians investigated whether radio waves could be used to transmit signals. Ferdinand Braun contributed to wireless signal technology in several ways. In the late 1890s, he developed electronics in transmitters to reduce signal weakening and disruption between different transmitters. As you can see, coming from the Nobel Prize official site, if you follow this link, you get there. Then some biographical information also coming from this site, slightly summarized by me. Carl Ferdinand Braun was born on June 6, 1850 at Fulda, that's in Germany, where he was educated at the local Gymnasium grammar school. He studied at the universities of Marburg and Berlin and graduated in 1872 with a paper on the oscillations of elastic strings. He worked as an assistant to Professor Quinke at Würzburg University and in 1874 accepted the teaching appointment to the St. Thomas Gymnasium in Leipzig. 2 years later, he was appointed extraordinary professor of theoretical physics at the University of Marburg, and in 1880 he was invited to fill a similar post at Strasbourg University, that's in France. He was made professor of physics at the Technische Hochschule in Karlsruhe in 1883 and was finally invited by the University of Tübingen in 1885. One of his tasks there was to build a new physics institute. 10 years later, in 1895, he returned to Strasbourg as principal of the Physics Institute, where he remained in spite of an invitation from Leipzig University to succeed G. Weidemann. Braun's first investigations were concerned with oscillating strings and elastic rods, especially with regard to the influence of the amplitude and environment of rods on their oscillations. Other studies were based on the thermodynamic principles, such as those on the influence of pressure on the solubility of solids. His most important works, however, were in the field of electricity. He published papers on deviations from Ohm's law and on the calculations of the electromotive force of reversible galvanic elements from thermal sources. His practical experiments led him to invent what is now called Braun's electrometer and also a cathode ray oscillograph constructed in 1897. In 1898, he started to occupy himself with wireless telegraphy by attempting to transmit more signals through water by means of high-frequency currents. Subsequently, he introduced the closed circuit of oscillation into wireless telegraphy, and he was one of the first to send electric waves in definite directions. In 1902, he succeeded in receiving definitely directed messages by means of inclined beams antenna. Braun's papers on wireless telegraphy were published in 1901 in the form of a brochure under the title Drahtlose Telegrafie durch Wasser und Luft, wireless telegraphy through water and air. After the outbreak of the First World War, Braun was summoned to New York to attend as a witness in a lawsuit regarding a patent claim. Owing to his absence from his laboratory and due to illness, he was unable to carry out further scientific work, and Braun thus spent his last year of his life peacefully in the United States, where he died in April 20, 1918. Slightly summarized by me, and the original you can find here. By the way, I have to make one self-correction. I just said Strasbourg is in France. It is now, but at that time it was in Germany. Okay, let's go on with Guglielmo Marconi work, also coming from the Nobel Prize. In the late 1880s, previously unknown type of radiation was discovered, radio waves. It was found to have the same nature as light, but with a greater wavelength. Various physicists and technicians investigated whether radio waves could be used to transmit signals. We've already heard that with Braun. In 1895, Guglielmo Marconi used radio waves to transmit signals over a distance of several kilometers. He had developed the technology in subsequent years to achieve greater range. The foundation for both wireless telegraphy and radio had been laid. Coming from this place on the internet. Then some biographical information, also coming from the Nobel Prize site, slightly summarized by me. In 1895, he began laboratory experiments at his father's country estate at Pontecchio, where he succeeded in sending wireless signals for a distance of 1.5 miles. In 1896, Marconi took apparatus to England, and later that year was granted the world's first patent for such a system of wireless telegraphy. He demonstrated this system successfully in London on Salisbury Plain and across the Bristol Channel, and in July 1897 formed the Wireless Telegraphy and Signal Company Limited. In the same year he gave a demonstration to the Italian government at Spezia, where wireless signals were sent over a distance of 12 miles, and in 1899 he established wireless communication between France and England. He erected permanent wireless station at the Needles, Isle of Wight, at Bournemouth, and later at the Haven Hotel Pool in Dorset. In 1900 he took out his famous patent number 7777 for tuned or syntonic telegraphy, and on an historic day in December 1, determined to prove that wireless waves were not affected by the curvature of the Earth, he used his system for transmitting the first wireless signals across the Atlantic, a distance of 2100 miles. Between 1902 and 1912, he patented several new inventions. In 1902, during a voyage in the American liner Philadelphia, he first demonstrated the daylight effect relative to communication, and in the same year patented his magnetic detector, which then became the standard wireless receiver for many years. In December 1902, he transmitted first complete messages to Poldhu from station at Glace Bay, Nova Scotia, and later Cape Cod, Massachusetts. So that's across the ocean. The early tests culminating in 1907, opening of the first transatlantic commercial service, after the first shorter distance public service of wireless telegraphy had been established. In 1905 he patented his horizontal directional area, and in 1912 a timed spark system for generating continuous waves. He returned to his investigation of short waves, which he had used in his first experiments. After further tests by his collaborators in England, an extensive series of trials was conducted in 1923 between experimental installations at the Poldhu station and Marconi's yacht Electra. And this led to the establishment of the beam system for long-distance communication. Proposals to use this system as a means of imperial communications were accepted by the British government, and soon the first beam station linking England and Canada was opened in 1926. In 1931, Marconi began research into the propagation characteristics of still shorter wave, resulting in the opening in 1932 of the world's first microwave telephone link between the Vatican and the Pope's summer residence. 2 years later, he demonstrated his microwave beacon for ship navigation, and in 1935, again in Italy, he gave a practical demonstration of the principles of radar, of which he had first photoed in 1922. As I said, all information coming from the official site. Here's the link, slightly summarized by me. You see Braun again at work, this time in Helgoland. You see here his equipment and his collaborators. And here you see Marconi's first transmitter using antenna. You can read it yourself. An induction coil in the center, telegraphy here, and left the spark gap. These were all probably made by himself. Okay, then we continue with the awards for money speech by H. Illand. Summarized by me again. Research in physics has provided us with many surprises. Discoveries that at first seems to have but theoretical interest have often led to the inventions of the greatest importance to the advancements of mankind. And if this holds good for physics in general, it is even more true in the case of research in the field of electricity. The discoveries and inventions for which the Royal Academy of Sciences has decided to award this year's Nobel Prize for Physics also have their origin in purely theoretical work and study. Important and epoch-making, however, these were in their particular fields, no one could have guessed at the start that they would lead to the practical applications witnessed later. While we are this evening conferring Nobel's Prize upon the two of the men who have contributed most to the development of wireless telegraphy, we must first register our admiration for those great research workers, now dead, who through their brilliant and gifted work in the fields of mathematics and experimental physics opened up the path to great practical applications. It was Faraday, with his unique, penetrating power of mind, who first succeeded the close connection between the phenomena of light and electricity, and it was Maxwell who transformed his bold conceptions and thoughts into mathematical language, and finally it was Hertz who through his classical experiments showed that the new ideas as to the nature of electricity and light had a real basis in fact. To be sure, it was already well known before Hertz's time that a capacitor charged with electricity can under certain circumstances discharge oscillatorily, that is to say by electric currents passing to and fro. However, was the first to demonstrate that the effects of these currents propagated in space with the velocity of light, thereby producing a wave motion having all the distinguished characteristics of light. The discovery, perhaps the greatest in physics throughout the last half century, was made in 1888. It forms the foundation not only for modern science of electricity, but also for the wireless telegraphy. But it was still a great step from laboratory trials in miniature, where the electrical waves could be traced over but a small number of meters, to the transmission of signals over distances. A man was needed who was able to grasp the potentialities of the enterprise and would overcome all the various difficulties which stood in the way of the practical realization of the idea. The carrying out of this great task was reserved for Guglielmo Marconi, even when taking into account previous attempts at this work and the fact that the conditions and prerequisites for the feasibility of this enterprise were already given. The honor of the first try is nevertheless due, by and large, to Marconi, and we must freely acknowledge that the first success was gained as a result of his ability to shape the whole thing into a practical, usable system, added to his inflexible energy with which he pursued his self-appointed aim. Marconi's first experiment to transmit a signal by means of Hertzian waves was carried out in 1895. During the 14 years which have elapsed since then, wireless telegraphy has progressed without pause until it has attained the great importance it possesses today. In 1897 it was still only possible to effect a wireless communication over a distance of 14 to 20 kilometers. Today electrical waves are dispatched between the old and the new world. All the large overgoing steamers have their own wireless telegraphy equipment on board, and every navy of significance uses a system of wireless telegraphy. The development of a great invention seldom occurs through one individual man, and many forces have contributed to the remarkable results now achieved. Marconi's original system has had its weak points. The electrical oscillations sent out from the transmitting station were relatively weak and consisted of a wave series following each other, of which the amplitude rapidly fell, so-called damped oscillations. As a result of this was that the waves had a very weak effect at the receiving station, with the further result that the waves from various other transmitting stations interfered, thus acting disturbing at the receiving station. It is due above all to the inspired work of Professor Ferdinand Braun that this unsatisfactory state of affairs was overcome. Braun made a modification in the layout of the circuit for the dispatch of electrical waves, so that it was possible to produce intense waves with very little damping. It was only through this that the so-called long-distance telegraphy became possible, where the oscillations from the transmitting station as a result of resonance could exert a maximum possible effect upon the receiving station. The further advantage was obtained that in the main only waves of the frequency used by the transmitting station were effective at the receiving station. It is only through the introduction of these improvements that the magnificent results in the use of wireless telegraphy have been attained. In recent times, research workers and engineers toiled unceasingly on the development of wireless telegraphy. While this development can lead, we know not. However, if the results already achieved, telegraphy over wires has been extended by this invention in the most fortunate way. Independent or fixed contact routes and independent of space, we can produce connections between far distant places over far-reaching waters and deserts. This is the magnificent practical invention which has followed upon one of the most brilliant scientific discovery of our time. Well, this is the summary of the award ceremony speech. Again, you can see the link here. It will also be links will also be in the description under the video to the Nobel Prize site. Well, a few illustrations. Here you see one of the inventions made by Braun, in this case the resonant transformer. He and Marconi developed a lot of their equipment themselves. That's often happens with pioneers. And here you see Marconi demonstrating his first long distance transmissions over the radio. At the right you see here the transmitter, and you see the receiver, and of course there had to be another pair at another place. I would say that speaks for itself, but say it anyway. Well, thank you for watching. Next week we will go into this physics prize again, and then we will deal with the lectures given by Braun and by Marconi. For now, thank you for watching, and maybe until another time.